Today we're going to work with our ratios once again, and we're going to talk about proportional reasoning with ratios. So we're going to be solving proportional situations, but we're going to focus on ratios today. And we're going to give you some ideas on different strategies, and just because I've chosen a strategy doesn't mean you need to use the same strategy. So what I recommend actually in this video is every time you see a question, you should pause the video, try the question, see how you do, and then play the video and see if your strategy matched mine. And if it didn't, and you got to the same answer, why is your strategy also correct? So there's lots of different ways of doing these questions as long as you're using proportional situations. So 3.4 as compared to 2. We want to simplify these ratios. So when I say simplify, I mean your final answer has no fractions or decimals, and it's in lowest terms. In other words, there is no GCF that goes into both of them. For example, in the first one, 3.4 is a decimal, so it's not in lowest terms. So I need to eliminate the decimal, and with a ratio or a fraction, right, whatever you do to one side, you must do to the other. You could double it, triple it, quadruple it, anything you like. Whenever you have a decimal, a nice easy one to choose is to multiply by a power of 10, 100, 1,000, because that moves the decimal to the right. So if I multiply the left side by 10 and the right side by 10, I've eliminated all my decimals, and now I can reduce. Oh, I can see that 2 goes into both sides. So that is a 17 to 10 ratio in lowest terms. If you have a fraction, same thing. You want to multiply both sides by something that will eliminate the fractions, just like I eliminated the decimal. But here you don't want to use 10, 100, 1,000, because now we're not dealing with tenths, hundreds, and thousands with decimals. We're leaving, this one deals with thirds and this one deals with fourths. So we have to find a number that thirds and fourths both go into, and I see that they both go into 12. So if I multiply the right side by 12 and the left side by 12, my ratio stays in proportion. So if I multiply 3 over 4 by 12, or in other words, by 12 over 1, I can see canceling. The 4 goes into 12 3 times. I'm left with a 9 on the right side. Same thing on the left side. The 3 goes into 12 4 times, and I'm left with 4 on the 9 on the left side. So we have 4 as compared to 9, no decimals, no fractions, and no GCF between the two terms. Here's another one. The first one has 1 decimal place to eliminate. The second one has 2 decimal places. So I'm going to multiply both sides by 100. When you multiply by 100, the decimal moves 2 places to the right. So you end up with a ratio like this. And then you say, well, let's start reducing. I can see that 5 goes into both, right? Because it ends in 0, ends in 5. So you divide by 5 and you get 126 as compared to 9. And then you wonder, well, I wonder if 3 or 9 goes into 126. Now remember, if the sum of the digits adds up to 3, it's divisible by 3. If the sum of the digits adds up to 9, it's divisible by 9. 6, 7, oh, it is divisible by 9. So let's divide by 9, and I get 14 as compared to 1. All right. And then over here, 6 and 9, I could choose 54, but choose the lowest number they both go into, and it helps with reducing later. I can see 6 can become 18, and so can 9. So I'm going to multiply the left side and the right side by 18, or 18 over 1. I'm going to look for my canceling, then I multiply. I'm going to look for my canceling, and then I multiply. You should always be able to, this number here on the bottom should always go evenly into this number, and vice versa. That number should always go evenly into this number, because you chose a number that they both go into. So you should always be able to say 6 goes into 18 so many times, etc. And then you end up with a nice ratio with no fractions or decimals. Again, a reminder, if your units are different, you make them the same so that you can eliminate the units. Ratios are unitless, therefore they can use that proportion on any single different unit you want, because it just stays in proportion with the same unit. So I'm going to change, I always like to change the bigger unit into the smaller. So I'm going to multiply by 1,000, and now I have milliliters as compared to milliliters, and so now I no longer need to write milliliters. Now I can divide both sides by 100, And now I can divide both sides by 3, and I get a 5-to-1 ratio. What happens if you have 3 terms, 5 as compared to x as compared to 3, and it's equal to y as compared to 6 as compared to 10? How can I find out what x and y are, those missing terms? What I like to do when I have ratios, sometimes I get confused as to which one lines up. I like to take the second ratio and line it up directly underneath the first ratio, right? So I like to line it up vertically, and therefore I can see, oh yes, the third term, I can say, well, how am I getting from 3 to 10? Whatever I'm multiplying, I do to all terms. Or how am I getting from 10 to 3? Whatever I'm dividing by, I do to all terms. Well, 3 times something, it's going to be a repeating fraction, or repeating decimal, sorry. And so if it was a nice terminating decimal or just an integer, I would just complete it by multiplying or dividing and be done. But since it's not, let's practice our cross multiplication. So you can take any 2 of the 3 terms to solve for x using cross multiplication. So you can go x as compared to 3, 6 as compared to 10, and now we can cross multiply. X times 10 is equal to 3 times 6. Divide both sides by 10, and we're going to get 18 over 10, and when we reduce that down, we get 9 divided by 2 over 5, and then we can leave it like that. We can change it to a decimal. We could write it as a fraction in lowest terms, 1 4/5, right, or 1.8, or whatever we do. So this is super accurate because we didn't have to round off and then multiply. So cross multiplication is nice and accurate. So now what we can do is, instead of taking those 2, I definitely need the 5 and the y because they have not been used yet, right? Oops. But what other one do I want to use? Well, the x, just in case I got it wrong, I don't want to use it. So let's use the 3 and 10. Let's give whatever's given in the question. It's always safer to go with what's given. So 3 and 10, 5 and y. 5 is compared to 3 is equal to y is compared to 10. Let's multiply again. 3y equals 50, right? 5 times 10. Divide both sides by 3. I get 50 over 3. And 3 goes into 50. I can just use my calculator if I want. I would get 16.7, 16.6 repeater, or as a fraction, you get 16 2/3, right? So all those different answers which are equivalent. 16.7 is just a rounded off answer. The ratio of red to black marbles is 4-11. If there are 450 marbles, how many marbles are red? Okay, so here's the key. 450 marbles represents a total number, right? It's how many you have completely. And 4 as compared to 11 is a part-to-part ratio. So the 450 is not the 4 or the 11 piece. It's not the red or the black. It's the red and the black together. So I'm going to give you a couple of options for solving this. If you have a part-to-part ratio and you're given the total, take this part-to-part ratio and write it as a part to whole. So I know the ratio of red is 4 out of 15 marbles. So I've created a part to whole ratio and make that equivalent to my part as compared to whole that I know I have. So you could write it like that, or as a ratio. You could have written as a ratio as well. Whenever I go part to whole, I usually write it as a fraction. Reminds me it's part to whole. And then you could cross multiply 15 times x, or hey, this one looks nice and easy. I don't think I have to cross multiply. I can just say, how am I getting from 15 to 450? I'm multiplying by 30, so whatever I do to the bottom, I do to the top. Therefore, x is 30. Oh, that's 120 red marbles, right? That's one way you can do this question. Another way you can do this question that some people like to teach is if this is a part to part and you know the total, well, you know that this ratio 4-11 is equivalent to, like, multiply both sides by 2 or by 3 or by 4, anything. It could even be multiply both sides by 1.38, right? It could be any number which we can call n. So 4n as compared to 11n is all equivalent ratios to this simplified ratio. So I know that when I add those together, if I have 4 multiplied by something plus 11 multiplied by something, I'm going to get 450 total in this case, right? Because if n is 1, I have 15 marbles. If n is 2, I have 8 plus 22, which is 30 marbles, right? Etc. I know I have 450, so what is n? What should I multiply each term by so that I can get a 450? So now I can collect like terms, and I could divide both sides by 15, and n is 30. Oh, I need to multiply that by 30. Therefore, I have 120 marbles as compared to 330 black marbles. So I now know how many red there are and how many black there are. So there's 2 different ways you can solve that question. Find 2 numbers whose ratio is 3 to 7 and whose sum is 150. This is another example of 2 numbers in which they add together or a total of 150. Again, you can choose one of 2 ways. Well, the first number out of 10, because those add to 10, the sum is 10. 3 as compared to a sum of 10 equals what as compared to a sum of 150? Times by 15 times by 15, right? Or we can say 3n plus 7n equals 150. Whoops. 10n equals 150, n is 15. Oh, so I just want to multiply by 15. So I get 45 as compared to 105. And that's how many, those are the 2 numbers. The 2 numbers are 45 and 105. They are in the ratio of 3 to 7, and they have a sum of 150. The width and length of a rectangular poster is 2 to 3. So 2 would be the width as compared to 3 to be the length. The perimeter, the sum of the outside edges, is 160. Please be careful with perimeter. Perimeter is twice the length plus twice the width, right? Or width, I said it backwards. Twice the width plus twice the length. So if we do not know what this width and length are, but we know they're in this ratio, again, we could put a little n there, can't we? So we know 2 of 2 n's, twice the width plus twice the length equals 160. We just don't know what n is, but we can figure n out knowing that if they are in proportion, n is a multiplier of each. So I get 4n plus 6n equals 160. 10n equals 160. Oh, n is 16. So I now know that n is 16. We can find the dimensions simply by multiplying by 16. So we know that 3 times 16 is 48 length. 2 times 16 is a 32 width. Okay, so again, we use that same concept. All right, here's a tricky one. 3 friends go shopping for shoes. Andy buys $75 pair, Brad buys a $60 pair, and Carlos buys a $45 pair. However, they share a coupon, buy 2, get 1 free, and the cashier rings up $135 for the 3 pairs. How should the friends pay for the shoes? So, if all 3 of them were going in together, and Andy got the most expensive pair of shoes, it wouldn't be fair to just go 135 divided by 3, right? If they just went 135 divided by 3, Andy is not getting that much of a savings, where Carlos would be getting a lot of a savings, right? Because Andy should be paying for more of the shoes, right? Actually, I think I said it backwards. Andy should be getting a proportional discount as compared to Carlos, right? So whoever pays more should still pay more after the discount is taken, right? So Andy would get the best deal. I think I might have said that backwards, but I think we get the idea. All right, so we have these three pairs. How much should they all pay if we want to keep it in proportion? Well, we know that Andy paid $75 out of the 180. That was the proportion of what he chose, because 75 plus 45 plus 60 is 180. And so we want to know, what proportion should Andy pay? What proportion should Andy pay if they're only paying 135, right? And then we would do the same with Carlos. Carlos is paying 45 out of the 180. What proportion should he pay for if he's only out of 135? And then we do the same thing with Brad, who is paying 60 out of the 180, and then we can figure out what proportion out of the 135, right? Because we want to figure out what proportion of the total price did they pay towards. So through cross multiplication, we could figure that out, or we could figure it out proportionally. What am I dividing by? I divide by the same number. And we should be getting the numbers for the first one. We should be getting Andy pays $56.25. For Carlos, we should be getting, Carlos pays $33.75. Check your answers if you did it on your own before watching the video, or maybe you did it a different way and got to the same answer, which is great, because there's not always one way to solve a problem. There's different ways to think, as long as we're thinking proportionally. Whoops, $45, not $450. That would be fair to Brad. So $45 for Brad. So those three add up to $135. And Andy should be paying more since he got the more expensive shoe, and it's fair because it's all in proportion to the total price that they first bought into.